if you're here for AI and large-scale processor design, I think you're in the wrong room. I went to OCP last week. It's amazing seeing the AI scale. This is more on the low-end embedded side. So yeah, but it's great to see a large community here. Yeah, so I'm here to talk about Ibex and the future of it. So it's a 32-bit microcontroller. It's RISC-V. So firstly, I'm just going to give a little bit of a history. So low risk, so the name, key is in the name, so RISC-V. We were founded 11 years ago, so our birthday, as mentioned in the lightning talk yesterday, was a couple of days ago. We're a spin-out from Cambridge University, so we're based in Cambridge, UK, and we also have offices in Zurich. We're a non-profit organization, and the aim, our tagline is to drive open source silicon everywhere. So that's our mission. We have a full stack engineering team, so I'm supported by a large number of very talented individuals who are experts in RISC-V processor design and also open source silicon in general. We're currently about 25 people, but we're growing. There's a lot of different projects that want to use the open source IP. And then we have support staff, and as I mentioned, we're based in 2 sites, one in Cambridge, UK, and then Zurich in Switzerland. We were one of the founding members of the RISC-V Foundation, which is now RISC-V International, so here we are, and also CHERI Alliance. We are a steward and maintainer of both OpenTitan and Ibex. Going into that, why use open source silicon? So if you go back 20 years, when I was starting as a software engineer, I looked at open source software. Why is this important for the hardware world? Well, you can see some of the example projects, GNU, Android, etc., Linux, various projects have been out there. We are trying to make the same happen for hardware design. Also, if you're involved in silicon IP fabrication, you'll know that it's a very fragile market, and sort of COVID showed how not having open source IP was a real challenge. So we believe that there's 2 columns here. The left is kind of how people generally work. Lots of it is in red, so red is bad in this case. But we wear red as well, so it's not always bad. But this is how hardware manufacturing is done. And then for projects like OpenTitan, we're trying to demonstrate where we can actually get a lot of the IP done in open source and trying to make that all green. And so we've got 2 projects, Ibex and OpenTitan, that we're pushing. One word on OpenTitan, so that's the hat we're wearing. So OpenTitan is a secure root of trust. Being a UK predominant company, we like teas, so we have Earl Grey and Darjeeling. This is a diagram of Earl Grey. Hopefully it's come out okay. So Earl Grey uses Ibex in a specific configuration. So it's a dual-core lockstep configuration, and it's been SCA, FI hardened, security hardened, and we're using it as a demonstrator for various other things. And I'll go into where it goes into products, and it's got some post-quantum support. I won't quiz you on every block that's in this diagram. Feel free to come and speak to us later about it. So cast your eye back to last year. So RISC-V Munich, we announced that OpenTitan, open source silicon could get to market. So we're very pleased to sort of say that OpenTitan is now going into volume production. So the chip that was shown by in Munich, that's now going to be in Chromebooks. So if you are using a Google Chromebook, it's going to be secured by this chip. Also, if you use Google's data centers, so Gmail, whatever service, it's also going to be protected by this. So quite a good case for showing how we are commercially viable. So the key thing for people like Google, our partners on this project, is that we have to have very highly verified code. We have to make sure that it's validated and analyzed everywhere. And so people need to be able to understand the design. Coming to the core of what this talk is about, so Ibex. So it's a 32-bit highly configurable core. There's many different features that you can use, so I won't go into all the details here. But the main thing is that based on the projects we're using, you can understand that security, memory safety, all of those things are of interest to us and a concern. So this core is designed with those things in mind, and we are very happy that it's been looked at by many developers. If you're using Ibex and OpenTitan, please come up to our stand at the end as well. We'd like to know about people using it. It's all Apache 2 licensed. So memory safety. This is just a little plug for a colleague's talk. Memory safety is a big concern. See massive amounts of issues still with CVEs. And the challenge here is that we still see lots of memory bugs. So we're also at lowRISC, we've been working on CHERI. So I won't go into CHERI too much, but it's essentially to say that this is a hardware way of looking at solving some of the memory safety problems instead of using software solutions like Rust, etc. And we've got colleagues here in the room who've worked on CHERI, and there's various other talks on CHERI. Then Chariot, so Microsoft quite liked CHERI, they quite liked Ibex. They put that together with an RTOS, and they made Chariot Ibex. So also just to quickly highlight some of the history. So originally Ibex was one of the Pulp projects, so ETH Zurich and Pulp. We took over the maintainership of Ibex, so we look after it, and then Microsoft took it to Chariot Ibex. And then, so just a few more details on this. A nice quotation from Tony Chen. So why is CHERI important? Answer is that it makes memory safety a core feature. So we're extending Ibex to do CHERI Ibex. One thing that does have to happen though with CHERI is that you need to extend the design. So you need to change the register layout. You need to make some changes to make CHERI supported. It's ISA independent. So ARM released this with Morello. There's no x86 implementation, but lowRISC, we're helping do this for RISC-V. Many others in the community that are also in the audience are working on this. So you need to change the hardware to get that supported. The challenge, so Microsoft looked at our open source project. We like people using open source. It's part of what we do. They took a fork quite a while ago now. So like any of open source projects, they can take a fork at any point. But there's lots of challenges. They've kind of went on one path. We've obviously been doing fixes for OpenTitan to get it production grade. So one of the future items is that we're going to be looking to try and get Ibex and CHERI Ibex to converge again. We're working with Microsoft to see how that story can come back together. And the main reason for this is that we've done lots of work with labs, we've done lots of work with vulnerability assessments, etc. So we need to make sure that all those nice bug fixes that have been found by the community, by others, can be adapted and brought back in. So the plug, yes, if you are interested more in CHERI and Chariot in particular, please visit my colleague's presentation, Mano. It'll be in the level 2 theater straight after this presentation. Glad that we didn't move the agenda slots, but yeah, Mano will be giving a talk on that. Another key thing that I'd like to highlight is that for people to say that this core is production grade, we put a lot of work in, and we've worked with Oxford University Innovation, Oxford University, Tom Mellom, various others, Louis Emile, to do formal verification of the CHERI Ibex core. And this is to show that sale spec of what CHERI Ibex complies with the RTL that's available. And we have an open source flow. We've been working with Microsoft to make that all accepted. So we've been doing quite a lot of work to make sure that this all comes in. We announced some stuff about the formal verification a little while ago. If you're interested, again, please come and talk to us. So that's a lot of the history and sort of some key features. Some of the things that we're seeing now, so get to the essence of the talk. We're 6 minutes to go. We are looking at, in the embedded sort of microcontroller, resource-constrained world, some features that push this really into smaller targets. So it's not the AI sort of massive SoCs that, talking about gigawatts. We're looking at resource-constrained environments. So our customers, our end users, are looking at having compression. So ROM memory is really tight and all of these things. So we're looking at adding code size reduction. We're looking at adding all bit manipulation. So we want to make sure that this all aligns also with what's being done in the RISC-V community. So making sure that we come back, make sure that we're sort of bringing things back. Now, the other thing here is just quickly to say, so as we go into future products that leverage Ibex, there's a real demand for squeezing as much in as little area as possible. So PPA, so reducing everything. So we need compression. Obviously, that makes Ibex bigger. So you add more instructions, but you save more in the long run by squeezing this all in. So that's also important for people who are interested in post-quantum. So obviously there's been NIST specs and various other things talking about PQC. And you're going to have larger keys, larger signatures. So all of this compression is important or kind of essential. One of the other things that we are looking at is adding more bus interfaces. So currently it's using TileLink. That's kind of a historical reason, pure open source. There's Amber and there's AXI and various other interfaces which are industry adopted. We are looking now to move Ibex and the whole sort of designs to use these more widely adopted, widely industry adopted buses. So we are looking at how that can happen. We've taken quite a purist view, but we're looking to try and increase on this. The other thing to highlight is we're looking at iCache pinning, so making sure that we can pin lines, make sure that instructions can't be flushed. There's certain performance features, some performance optimizations that we were looking at. And so, Ibex is a community project. We would like people to suggest if there's certain features you would like, for you to bring those to us. Your ideas are essential for this all. If you have things that you would like brought in, we're wearing these very conspicuous red shirts, so we're at the back of the hall. So so I know I'm a bit ahead of time, but if you want to contribute, please go to our GitHub page. You can see here there's OpenTitan, that board, the whiteboard in the middle. That's using dual-core lockstep configuration of Ibex. We have various things where we're using CHERI CHERI Ibex. So this is the Sonata platform. So please, if you're interested, come and visit our booth. So with that, I'll probably end. Thanks. So we probably have time for quite a few questions if anyone wants. Tariq, the play.
I was going to ask if you're going to do CHERI versions of the code size extensions.
Yes, yes. We're obviously very interested in security and memory safety, and the thing here is that you can see that there's two worlds colliding. I can't go into too many details of what our but yes, we are looking at how we might do follow the CHERI Y standards, follow all the compression side of things as well. So definitely on the to be confirmed side.
Worth a future conversation.
Yeah, exactly. Yeah.
Okay.
No. Ravi, I promise these are not plugs.
I think we talked about this also, but just wanted to confirm, any plans to go to adding MMU support or 64-bit support?
So good question. So now I can hint that there is a new project coming along where we will be It's always a dangerous thing. So we will be announcing fairly soon a collaboration with Open Hardware Foundation, working on a project. We're waiting to get the contract signed, but we'll be looking at 64-bit, but this won't necessarily be with Ibex to begin with. So there's talks with John Woodruff and various others from Capabilities Limited. So there are things coming, but Ibex with 64-bit would be interesting, but there are other designs that have already considered this. So we're probably going to go that route first, and then look at what we do with IMMU, 64-bit in the future.
Thanks.
All right, thanks.
Okay, thank you.